In a prior lecture, you already discussed the retirement income need. In this presentation, what I would like to do is walk through some of the actual calculations. When we think about withdrawals, before we get into the calculations, there can be income withdrawals which are consistent throughout the retirement period, but more often we're taking a look at withdrawals that increase by the cost of living rate. And when we do that, we get into an inflation adjusted inflation factor, and we'll take a look at that. But as we proceed through these two examples, the idea is for each year in retirement, those withdrawal, the retirement income need increases by the cost of inflation. So let's look at the level payment. In the level payment, the idea is that we're going to be making consistent contributions each year up until that retirement period. So let's do an example, because it's always the best way of looking at calculations. And in this example, there are 35 years until retirement. The inflation rate, we'll just look at a long-term historical rate of 3.5%. The retirement need in today's dollars, if the individual is going to retire today, it would be $50,000. Realize that we need to consider what that would be 35 years from now, right? To be conservative, we always take out retirement income in our calculations at the beginning of the period, and we do that because that just lowers the amount of compounding could occur during the year. But this is a little bit more conservative than saying, certainly than assuming the money is going to come out at the end of the year or maybe partway through. So we'll use the beginning as an assumption. The client has a longevity of the expected longevity of 15 years in retirement. There are zero current savings. The reinvestment rate during that pre-retirement period is 8.5%. And for that matter, we'll just say a consistent 8.5% even into retirement. There is a legacy wish. In other words, the client would like to leave to their heirs a flat $1 million. And in this case, we're not going to assume that's going to increase by inflation. Legacy is received at the end of those 15 years, and any contributions made during the pre-retirement period is at the end. Again, we're doing that for purposes of being conservative, and this is what you would do on the CFP exam. The idea that the contribution isn't made until year end, but withdrawals during retirement are taken out at the beginning. And you realize by doing that, there's less compounding, so our projections are a little bit lower. That's conservative. So let's walk through the first step, and that is to inflate that $50,000 to year one of retirement. So we have $50,000. That becomes our PV now. I'm using an HP 12C, whether you're using a Texas Instrument or a 17B or whatever calculator. You'll look at the manual to figure out what that would be, but I think my explanation here is pretty consistent with what you'll be doing in your calculator. We're fairly consistent. So I'm setting the end. The contribution is going to occur at the end of each of those 35, at the end, 35 in, I is 3.5, PV is 50,000, 0 PMT, because in this case we're simply inflating it. In the next slide we'll get into those end of period contributions. And when I figure out the FV, I come up with 166,679. For everyone who's been through Business 591, this should look very familiar. You learn two real concepts in that course: time value of money and risk and return. And so all we're doing here is now saying, what will a $50,000 cost be in 35 years if that's going to increase at 3.5% per year? And our answer is 166,000. Step two then is to say, well, what are we going to need for the retirement lump sum? And I think that this idea of coming up with a lump sum nest egg is valuable in our discussions with our clients. Why do I say that? Well, first of all, life happens. Things change. And therefore, one number is never the exact answer to a person's retirement. First of all, we don't know how long they'll live. We don't know what their reinvestment rates will be. We don't know what will happen after that. But this gives us a very good starting point, at least in our projections, for helping the clients see what they need to start pulling together for some projections. We need to have that discussion with our client. We need to know there's still some risk in here because that future is uncertain, but the process of coming up with a retirement need makes sense to me. In this case, you see two calculations. And the reason there's two calculations is because we are assuming that those withdrawals, those PMTs, those systematic withdrawals that you get at the beginning of the period throughout retirement are going to increase by the cost of inflation. But that legacy, that final amount that needs to be there at the end of the retirement period, was going to just be a flat $1 million. If we wanted that to increase at the cost of inflation, then in fact we would simply look at that first line there and put $1 million in the FV and solve for PV. In this case, and I think it's good for purposes of example, I'm doing it both ways. We're added together to get that lump sum need. So the annual need at day one of retirement is $166,680. I include that in the PMT of the calculator. In this case, zero legacy, because that's that next line, right? Zero FV. There are 15 years in retirement, right? And look at the I. The I is the inflation adjusted reinvestment rate. And that is 1 plus the reinvestment rate divided by 1 plus the inflation rate. And that quotient minus 1 gives us 4.830918%. That will be our discount factor. And so you can see that based on the beginning of the year withdrawal, we need $1,834,566. That legacy amount, simply discounting that into the 8.5, right, because that's not going to change for 15 years, is $294,000. Adding those up, we're looking at a lump sum of $2,128,707. And again, if you've been in 591, you should be right on board following this, right? Determining the annual level contribution is easy at this point. We're using the future value of that $2,128,000 that you just calculated. We're looking at a investment horizon of 35 years. We have a investment rate of 8.5%. And you see in there stocks 11%. So you can see the 8.5 would be sort of a balanced, allocated, probably 60-40 mix, something like that. And then I calculate an annual contribution of $11,046.62. So if our clients put that in at the end of every year for 35 years, and that compounds at 8.5%, they would expect to accumulate in excess of $2 million. Level contribution. What's the serial payment? The serial payment is the idea that, well, wait a minute, we wouldn't have to necessarily make the same level payment for 35 years. That could be very difficult for our young clients who are just getting into their careers. What if we were to start at one level, increase that each year, which would be a better match between their career earnings, and maybe they could afford to do it. So the serial payment is slightly different. Again, this was the same slide you saw earlier with those rising withdrawals. But notice that those first 5 vertical arrows pointing to the top of the slide are increasing. And that's that idea that we're going to have systematic contributions again, but this time those systematic contributions are going to increase at the cost of living, which means that some of those early contributions will be less than what was required with the level, but later it would have to be more than which was required by the level, right? So how do we calculate this? Well, steps 1 and 2 are identical. We're simply going to inflate what the current need would be today to that 35 years out when they plan to retire at the cost of living. That 166 becomes our what we need. Then we go through the idea of determining our lump sum with 166,000, which is going to inflate by the cost of inflation. We worked through this before. There's a legacy amount. We still have to come up with 2,128,000, but this is where the calculation starts to change. And it's not, I don't think, intuitive, but I'm trying to try to walk you through the process. The first thing we do, we take that lump sum and we deflate that lump sum to day zero at the cost of inflation rate. So we have 2,128,702, which becomes our future value. PMT is not even part of this. We put in 0. We've got 35 years, which is our N. That's our investment period. And the inflation rate is 3.5%. And when you do that, we come up with a present value of $638,561.34. That number becomes our new future value. Okay? So we take that 638,561. We still have 35 years, but now we're looking at we need to determine how much needs to be put in each year using an inflation adjusted rate. And this is where it might not become intuitive, but you can see it'd be 1.085 divided by 1.035. That quotient minus 1 gives us 4.8309%. Again, that's 1 plus the reinvestment rate divided by 1 plus the inflation rate. And you know that 8.50% is the same as saying 0.085, right? So that'd be 1 plus 0.085 divided by 1 plus 0.035, quotient minus 1. We come up with a payment of 5321.33. But that is actually the rate as of today. To get the payment at the end of the year, you would have to inflate that by the inflation rate. So 5321 becomes 7577. That would be the contribution at the end of the first year. The contribution at the end of the second year would then increase again by the cost of inflation. So 777.58 times 1.035 becomes 5842. And you would follow that process for the next 33 years. Each year, that contribution would increase by 3.5%. So that is the process of doing the serial payment. Again, steps 1 and 2 are identical. The difference is, rather than solving for a level, you are deflating that lump sum to day 1. You're then using that as your future value, and you're then working through that, inflating each one through. You have the slides to take a look at, but when you go to the client, and you can say, we can do a level payment, we could then also replace that with a serial payment, so you can cut down your payments in the beginning, gives you another tool, another methodology. In the next presentation, we'll add one more methodology. That's age banding methodology, which can be a very, very powerful tool in helping your clients achieve their goals.